Brendan Caulfield is an dom. Tá fáilte mór romh agus gam, buchas liv as teacht an seo. Anot teastín óim sibh a chuairt ar thús. Ag tusnú díreach an seo agus ag dul beagnach chomh ad a gúr féidir. I dro gúr féidir fille éireas a bhaile. Chun ceist na híthe a ragart. Cá bhfuil méid. Tá féile orm nach bhfuil mé in an trús siú a dhéanamh as céilge, as béarla a bheith mé ag i labhart. Ach gabhaim buchas ó chrí le Michelle, Breege, Adrienne, agus Claire, agus an coiste leis seo a thuairt dom agus an fáilte chrí ó a thug si ó dom. Tá bhur gabhar anois, tar in éanacht lom ar an dros chun ar ná it is spás a I'm sure our place in space. So good evening everyone. Sorry if I murdered our national language there. But it's not my forte, unfortunately, so I'll have to continue in English. Thank you very much, all of you, for coming. And in case it wasn't clear, I just wanted to thank Breege over there for emceeing tonight, and Michelle for setting this up, Claire for taking over, and of course the hospitality of Adrienne and Paul for providing the venue. So thank you very much for that. And of course, Phil and Gaelic for making it all possible. So our question of the night is possibly one of the oldest questions that humanity has ever asked itself. It's, where are we? So I want a little bit of help from all of you with answering that question. So first of all, let's just ask the question literally. Where are we right now? Can anyone tell me where we are? Someone said Bhric? I think you're right. Give me a little more detail. Where is that? Where is Bhric?
Riasc. Middle of nowhere.
Middle of nowhere. And where in the middle of, or where is that middle of nowhere? Where is that nowhere?
In the middle of nowhere.
We're in the northern hemisphere.
We have a clue on the screen. In the northern hemisphere is an excellent way to put it as well. That's skipping a few steps. But I would say it's in the south of Ireland. Ireland's in Europe. And indeed, we're in the northern hemisphere of this planet here, called Earth. And you know the way when some of us maybe are still in school, but when I was in school, I was asked to write a letter as part of an English or Irish assignment. I would always go overboard on the address, you know, Europe, the world, the solar system. Well, that's kind of where I'm going with this. So we zoom out from the Earth. If I turn on the orbits, for which I have a few too many things selected. But anyway, you can see the orbit of the moon there. We have the orbit of the Earth. And then the orbits of the other planets. And complicating things are a few comets and such in the background that I should have filtered out, so apologies for that. But we're now looking at our solar system. So that's like, depending on how much detail you want to go into, maybe the 5th or 6th line of our address, right? And does anybody know where our solar system is?
In the middle of nowhere.
Yeah, well, very accurate. But there is a name for that, nowhere. The Milky Way, exactly. So we are in, if you want to get really pedantic about it, we're in the Orion spur of the Milky Way galaxy. And as I zoom out a lot further now, you can see up here, this is my speed that I'm moving every second. I was just increasing it there as I'm going. So this is thousands of light years per second right now. And I'll get back to what a light year is in a moment. Also, just a few settings on the fly. Right. So, there's the Milky Way. And sort of of photobombing us there in the background. A lot of other, what look like stars. But that is starlight, but it's every pinprick of starlight there is hundreds of millions of stars. So the further we go out, the more sort of mind-boggling the scales become, the faster I have to move to bring us out into the universe. And let's get another little bit of help here. Does anybody want to navigate for me? All I need from you is to...
somebody.
Yeah?
I see somebody.
Someone here?
Yeah.
Oh, okay. Would you like to choose a destination? You just need to point at the screen. Well, so I can tell where you're pointing. Come up here. Okay, that bright one there, yeah? So, this one there. Right, let's get a little info about it. So, as I said, every dot of light on that screen is a galaxy. Now, just to recap, we're on a planet, planet's in a solar system, and solar systems orbit around a big cloud of solar systems called galaxies. And so each of these dots of lights are big clouds of solar systems. And there may be hundreds of billions of solar system in every one of these dots of lights. And as we come in on this one, okay, so it's got a nice round shape. It's quite dark and cloudy. So there's a lot of dust and gas in between the stars. And as we fly in closer, we see there's a lot of blue stars. So there's also quite a number of red ones as well. So blue stars are younger stars. They're only a few million years old. That's all. The red ones may be hundreds of millions or billions of years old. So does anybody else want to pick a destination? Oh, sorry. Which one?
That one.
Okay. Thank you very much. Gurmilamaga. And we'll fly into that one. And so this is where things get interesting, because what we're looking at here is a star in another galaxy, and it more than likely has some planets around it. It's actually a lot further away than I thought it was. I'm going to cheat and use the auto travel to get there. So we just flown right down to basically the surface of the star. So this is a blue main sequence star. I'll turn off orbits just so I can have a little bit of fun with finding them. Now at the moment, the way we're seeing it is kind of like how the best camera in the world might see it, or the best camera in the universe in this case, where the brightness of that star has been dimmed down so much that we can't see the background stars. But I can kind of turn on magic camera mode, and then we can see the other stars. Because if we were looking at that with our normal eyes, it wouldn't be fun. Anyway, we'll turn on orbits again and we'll find some planets, because that's where the interesting stuff happens. So that ring there is the path of an orbit of a planet, and this right here is that planet. Target that, get a little information. So this is a very hot planet, and I've overshot it. Sorry, my piloting skills are a little rusty. I haven't been doing this for a while because of the pandemic. Getting close. Right. Turn off orbits. And there's a few dots there. So that's a planet with a few moons. Let's get a look at it. We can talk about what kind of planet it is. Right, so this is an Earth-like planet. It's got a rocky surface, it's got an atmosphere, we can see clouds, we can see land masses. As we're getting closer, we can start to see rivers, storms, mountains, volcanoes. So, funnily enough, being so similar to Earth and yet extremely hot, I mean, it's 470 odd degrees on that planet there. It's one of the less interesting planets that we could look at, because weird is interesting, right? So, we maybe will come back to this, or to another planet, and let's go home first. We'll take a tour of our own solar system, look at the weird planets that we have on our doorstep, so to speak. So that's our sun. Who knows what the first planet from the sun is?
Vulcan.
Old school. So who knows what the first planet that hasn't been confirmed not to exist is? Mercury. So let's take a look at Mercury. Oh, there's comments of orbit. So the green lines are planets on Mercury. So Mercury is an interesting world. So it looks a lot like our own moon. And it is similar in the sense that it is sort of a barren rock. It's airless. There's like a tiny bit of an atmosphere on it, but it's mainly just sort of gases given off by the rocks, because the sun is so close at hand. It's kind of baking the rocks. And the baking of the rocks is helped by the fact that it has an extremely slow orbit, or slow rotation. So it turns on its axis, I think, like once for every 1.5 or 2.5 rotations around the sun. I can't remember the exact ratio of that. But that means that the day is actually longer than the year on Mercury. And so one side of the planet is getting cooked by the sun for months on end, and the other side is freezing, and then gradually it's rotating around and that relationship is swapping. So everything is getting heated up and sort of expanding, and then getting cooled down and sort of contracting. So you get this kind of weathering effect on the surface of Mercury. That's why, even though you can see craters, you can kind of see that there's craters that have been almost sort of eroded away here, older and newer. But again, very slow process, so that takes a very long time. So the next planet from the sun, does anybody remember what the next one is? Venus. Nice. Turn on worlds again just to help in finding it. So one of the things, this is the real scale of the solar system. So you'll see me kind of struggle to find things sometimes, because look at how tiny the planets are compared to the vast spaces in between, and that's almost an exaggerated glow that we're seeing from Venus right here. Venus is one of the brightest objects in the sky, so you know that's fairly accurate in that case, but still it's difficult enough to spot them and to slow down when you're flying at them at a good chunk of the speed of light. So Venus, this is the most Earth-like planet in our solar system, but it is also one of the weirdest ones. I said earlier that you know, Earth-like planets are not that interesting when we're looking for something that's unusual and different than outside of our field of knowledge. But Venus, despite being very similar in size to the Earth, having roughly the same surface gravity, is nothing like Earth to stand on. See all of the whiteness of it? That's a cloud deck of sulfuric acid clouds. So if you went there, you'd start to dissolve because of the acid. It's horrible. But not only that, the atmospheric pressure is something like, it actually says it here somewhere, I think. Nope. It's something like 50 times Earth atmospheric pressure. So you'd also be getting squashed. And not only that, the cloud deck traps heat from the sun in an effect that we call the greenhouse effect, which of course is a concern here on Earth at the moment. But Venus's greenhouse effect is off the rails. The surface temperature, according to this, it's 174, but I know it's a lot harder than that. It's like 500 degrees Celsius on the surface of Venus. So if you go to Venus, look forward to being dissolved, crushed, and roasted. not a good holiday destination. But actually, if you let me skip around a little bit, in terms of holiday destinations, I think the most enticing place in the solar system for a holiday, just counting planets now so I get my bearings, yeah, will be over here, a moon of Saturn. So here's Saturn. Saturn is just beautiful. The first time I actually looked at Saturn through the telescope, I genuinely shed tears because it's like a diamond. It's if I turn on the realistic view, sorry, auto, it shines through your telescope. Yeah, like that. That's kind of what it looks like through the telescope, and it's just like, oh, so beautiful. Anyway. One of the moons of Saturn is just my favorite place in the solar system, aside from Earth. I love Earth. Not yet, I want to. And I'll tell you why. So, oops, wrong button. Yeah, that's good. So, Tethys, Mimas, Dione, Titan. Right, so Titan is, I think it is the largest moon in the solar system. And it's also one of the only places aside from Earth where you have a liquid cycle. So there's a very thick atmosphere on Titan, which is unusual for solar system moons. But there's also a liquid cycle, but it's not water-based because we're really far from the sun here. If I target the sun, it is 9.89 AU. So it's nearly 10 times as far from the sun as we are right now. So it's not getting an awful lot of heat from the sun. A little bit of heat from the sort of friction and kneading that goes on in the core of it from the gravity of Saturn. As it's swinging around Saturn, there's just a little bit of, it's kind of like bread getting kneaded on a breadboard inside in the center of Titan in terms of the rocky core. So there's a little bit of heat from that, but not enough to make it livable. And certainly the temperatures there, like it's reading at minus 177 degrees Celsius here. So you're not going to have liquid water flowing. But what you can have is liquid methane, liquid ethane, and that's what the clouds are made of, ethane and methane. And under the clouds, although this program doesn't really do much justice to the surface, so I won't bother drawing down, but I'll tell you that the air is thick, like it's literally thick air. The gravity is about the same as our moon's gravity. And so if you were in an appropriately insulated spacesuit with an appropriate supply of oxygen and all of that so that you could survive on the surface of Titan, you could take a pair of trays from the cafeteria of your spacecraft, walk outside and flap your arms and fly. Because the air is so thick, the gravity is so low that you will get plenty of traction and plenty of lift just from doing that. And it rains ethane, or maybe methane, I can't remember which one, but it rains this, like, essentially what is indeed rocket fuel. But there's no oxygen in the atmosphere for the rocket fuel to burn, so it's just like raining rocket fuel. And because of the physics of those liquids and the way the air is and the gravity, the raindrops are the size of Christmas ornaments. So when it rains on Titan, it rains in slow motion with giant golden baubles. And it's so cold at the temperatures that stuff is liquid, that just the waste heat from your spacesuit would boil it on contact. So as you flap your cafeteria trays and fly through the mists of Titan, you'd be hitting golden raindrops that just sizzle and steam away. I just think that sounds so much fun. So that's where I want to take my holidays when solar system tours open up. So we were marveling at Saturn as we came in. Sorry, any questions so far?
Where are we?
Excellent question. Let's keep answering it. So we were marveling at Saturn as we came in. And you can see here, actually, Saturn, this is a good viewpoint because the moons around Saturn, almost all of them, certainly the ones closer in, orbit at the same sort of angle as the rings around Saturn. And you can see here, if we look zoomed in on Saturn, we don't see the rings at all. We see the shadows of the rings, but we don't see those famous rings. And if I zoom back out and start to move downwards, all of a sudden we can see them. They are incredibly thin. They're like razor thin in the sense of their width, because they're like, what is that, like 150, 200,000 kilometers side to side, and they're maybe 1 kilometer thick, probably less than that. Most of it is about 10 meters thick. So you can also see there's this like shine here. I'll get back into what that is in a minute. I just want to go in to the ring system itself and give you an idea of what actually that is. Because when I was a kid, I was looking at this and I was like, what is that? Like, is it a big ring of cardboard? Why is it yellow? How does it stay there? So let's get in real close. Oh, it is. You're right. Oh well, mystery solved. Now, there we go. So, this is a fairly accurate representation of what you might see. I don't know that they'd all be as round, but these are little chunks of ice. It's basically like snowballs. It's a haze of frozen ice, and some of that is coalesced into these snowball-sized chunks, and they go up to the size of like this building, but they're fairly rare. But this is kind of the debris, potentially the debris of a moon that got too close to Saturn and got ripped apart by the gravity. It's not confirmed that that's where they came from, but that's the thinking at the moment. And the reason that it looks so orderly and beautiful from afar is like, do you ever do those experiments in like secondary school science class where you get a jar full of gravel and sand and different sized stones, and you like shake it until it all self sorts into different sizes? You get the large stuff sitting on top and the finer stuff. Yeah, exactly. And this is essentially sedimentation writ large. So what's happening here is, if I have time paused, I'll just make sure I'm where's Saturn gone? Make sure I'm locked to Saturn so I don't fly off. But no, that's not it. Anyway. So if I unpause time, I'll get back into the snowstorm. It's so thin, it's kind of hard to navigate that, because you have to slow down at exactly the right time to get in. If I unpause time, it's suddenly all moving. And I'll slow time down so we can see which direction it's moving in, because that's not going to do that. This is, yeah, so now you can kind of see where they're going. Everything's moving in the same direction. And it's not really moving, like one snowball isn't moving left or right relative to the others. They're all going in the same direction. Because if any of them start moving left or right, they'll bump into others until they're kind of relatively stationary compared to one another. And all of that bumping and jostling is what does the sedimentation and forms those rings, those markings on the rings. And the reason they're all traveling in the one direction is because they're all orbiting Saturn. So this isn't a solid ring. This is an unbelievable number of incredibly tiny moons. And they're all orbiting around Saturn. And all that orbit is, I think the simplest way that it was explained to me that kind of enlightened me on what it is that orbit is falling towards a planet, or whatever you're orbiting, and missing it. If you're traveling sideways fast enough, and you have no air resistance because you're out of the atmosphere, you're not going to be slowed down by anything, and you can travel sideways fast enough that as you fall towards the ground is actually curving away under you. There's a certain speed you can get to where those two, the curve of the ground and the curve of your fall, match. And then you end up just falling around the backside and coming back to where you were. And that's what an orbit is. And all those trillions of particles of ice and snow are just falling around Saturn. And as they bump left and right into one another, they have self-sorted over millions of years into this beautiful sedimentation pattern.
How do they all orbit in one plane? Why are they not orbiting?
So similar to, so if you imagine, right, when I had that going at full speed, it was like a sandblast, right? And if you threw something into orbit, say at 90 degrees to it, so it was coming down here, it would enter into that plane where the rest of them are and get pinged. And so when the ring system was initially forming, it was probably pretty chaotic. So there was stuff orbiting at all different angles, but there would have been a bias in that towards a certain orbit. So more material on an equatorial orbit, because there are certain gravitational biases towards an equatorial orbit caused by the bulging of the planet itself. So things tend to get pulled towards that orbit anyway, but it's assisted by the fact that the more stuff that is in that orbit, the more objects that cross that orbit get pinged into similar orbits again. And so gradually over time, everything gets pinged onto the same plane. I'm not sure if that makes sense.
Question: if our moon fell apart, would it also form the Bhric belt like that, or would it, like, don't we have enough stuff, or?
Yeah, so the question would be, why is it falling apart as well? So if it was, well, in essence, yes, because you'd have some stuff falling towards the Earth, getting accelerated, some stuff going away from the Earth getting slowed down. So it would tend to, if it just blew up for some reason, it would tend to sort of initially form a sort of an S shape as it got preferentially sorted to faster and slower debris falling around the Earth. But over time that would evolve into this kind of structure, yes. But that also brings me to the salient fact here, because this ring system, as I said, it was potentially a moon that got too close to Saturn. And the way that process works is, if you've got, say you've got like an object the size of my fist there, right, in context, and on this side of it, gravity pulling from Saturn is slightly stronger, and on that side of it, it's slightly weaker. And when the difference between those two gravitational pulls from Saturn is more than the gravitational pull caused by the object itself, i.e. the gravity pulling things onto the ground of itself, if the gravity pulling from Saturn is enough to lift stuff off the ground, then the ground is just going to come apart, and the whole object just breaks up. And that distance is sort of a mathematical function of the size of the object and the distance from the planet, but it's called the Roche limit, and that'll be different, a different Roche limit for, you know, depending on what sort of object it is. So once there may have been an inner moon of Saturn and no rings, and that inner moon got too close for some reason and got pulled apart, and now we have one of the most beautiful sights in the solar system because of it.
But nobody lives there.
Not yet. Not yet.
Can you see that from the ground?
Sometimes.
The ring?
The rings, the Saturn, can you see that from
Yeah.
here?
You can. Yeah, I've seen them through my telescope. I mean, you need a telescope, or maybe high-powered binoculars and very good vision. But absolutely, you can see the
How
rings.
far away is that from Earth?
This is 10 AU, and an AU is an astronomical unit. It's the distance from the Earth to the Sun, which escapes me, but I think is like...
23 million miles.
Thank you. Who said it? Was that you?
Yeah.
Nice. You saved me.
930 million miles away.
Hang on, you just multiplied it. Oh, right, this is, yes. Fair. Yeah, so there you go. Yes, I was going to come back to this kind of ghostly looking ring here you can just barely see. That was relatively recently discovered. I think it was discovered on the Cassini mission. And there's a photograph that was doing the rounds back when that mission was running, and it looked like this. And it's when Cassini got into the essentially the shadow of Saturn and took a photo back of the sun, and that ring is refracting all of the sun's light into these kind of glowing spots. And I think it's really pretty. But the source of that ring is right there, actually. I think this is the right moon. It's in the right place anyway. Nope, that's not it. Let's turn on labels. No, it is. Okay. That's a weird shape. Ah, okay. I thought it was an oblong shape, but it's actually the shadow it's casting on the ring is what was making it look strange. So this is a moon, as you might be able to read on the screen, called Enceladus. And this is a really interesting little moon. It's an ice ball on the outside. You remember the way I said that Titan's core is getting kneaded like bread on a baker's board? Well, this little ball is, I think, diameter, 507 kilometers in diameter. So, you know, it's a little bit wider than Ireland is long. So it's quite small in planetary terms. But the core, it's relatively close to Saturn. And the core is getting kneaded so much by the gravitational changes as it orbits around Saturn that there is heat welling up through the bottom of that ice layer. And between 20 and 100 kilometers below the surface of the ice that you can see there is an ocean of salt water. And we know it's salt water because the Cassini probe that I mentioned passed through curtains or sheets of water vapor that were being thrown up through cracks in the ice. You can see one of the cracks here. And those cracks are in part caused by the expansion and contraction, like on Mercury, as the day side gets warmed up and the night side cools down. You get the ice sort of contracting and expanding against itself, and you get these large cracks then. When those cracks open up, there's no atmosphere above the water that's now been exposed. And water in a vacuum, I don't know if you've ever seen any video of water in a vacuum chamber. Water just boils spontaneously in a vacuum. If you go up the top of Mount Everest, you can boil water at 70 degrees Celsius. You don't have to get it to 100 degrees. And that's because the boiling point of water is dependent on the air pressure around it. And so when you expose liquid water to vacuum space, it instantly boils. And so you get these jets of steam, cold steam, coming out of these cracks. And the Cassini spacecraft was orbiting around Saturn. They adjusted its orbit so that it would fly past the pole of Enceladus, and it tasted the water as it went past. And like scientific instruments to do chemical analysis on it, but essentially it tasted the water. And it got salt, it got a few like sulfuric minerals and stuff. And that indicated that there are volcanic vents on the seafloor of this ocean under all of this ice. And they are very like the conditions that we think were pertaining when life began on Earth. And current scientific theory says that life began on Earth at volcanic vents on the seafloor. So there might be alien fish swimming around under that ice. And it would be really cool to find out. Can you imagine that though? I mean, like, it's very unlikely that there's intelligent creatures there. In fact, it's quite unlikely there's fish, because there's sort of a lot of scientific theory into like the energy available to life forms evolving in that kind of environment. There may only be microbes. But if there were thinking creatures there, and you suddenly appeared, you know, out of the ice ceiling that, as far as they were concerned, was the top of the world, and told them there's a whole other universe out there, imagine what they'd feel. It would blow their minds. So anyway, those steam curtains that I was talking about that Enceladus flew through, they go out into the local space, and then they form this E-ring. So that is the steam from the ocean of Enceladus that you're seeing there. Anyway, I could talk about Saturn all day. So shall we keep exploring our own solar system, or will we...
I just have a question before.
Yeah, sure.
So I remember hearing once like how, you know, Earth kind of formed, per se, right? That like, you know, you rock and then you have gases, and then there's like a cloud of gases, and then eventually there's a bit of moisture, which became kind of steam around the planet, which then turned into kind of droplets and rain, which then turned into kind of rivers and streams, which then turned kind of into an ocean, which kind of was then kind of waving all around planet Earth until the momentum got so strong that a huge bit of, like a massive big kind of tsunami wave just shot up into the atmosphere with a chunk of the, you know, rock material around from Earth, and that kind of, that's how the moon was made.
Yeah.
And that the crevice that it left in planet Earth is the bottom of the ocean now. Is that true? That like the moon is part of the Earth because of that, and then after that it all calmed down a bit and life began to form.
There were a few competing theories. There have been a few competing theories as to how the moon formed over the years, and it's still not. We still don't have a lot.
The baby of the Earth. That's the way I think of it.
Yeah.
If that was the case, that it's not totally separate.
No, and analysis of the rocks brought back from the moon indicates that it is our baby in a sense. Like that part is not. That's a lovely way of putting it. And your description, by the way, of the formation of the Earth was brilliant.
Well, it was from a fabulous essay written by Rachel Carson, who wrote Silent Spring. You know the book Silent Spring.
I can't say
She
it.
wrote a book about how the Earth, a short essay about how the Earth formed, and it's a fabulous essay.
Yeah.
It takes you to the whole thing. It's wonderful.
That's brilliantly put. And
But she kind of
the
said it that way, that like it was a big wave and then it just shot out. And
So
that's
part-
kind of what made the moon.
that part
It's like, wow.
that part was one theory that
Yeah,
was
it's
in contention for it.
changed since the 60s.
Yeah, exactly. That was the favorite theory in the 60s. Since then, there's another theory.
Although she was a scientist anyway, so yeah.
Well, she'd want to be to get it that
Yeah.
like that perfectly, because that's beautiful the way you put it. There's another theory that's more in favor now, which is similar enough. But no, I mean, as I say, it's not a lock. We don't know yet. It's just which theory has more backing at the moment, and that one has fallen out of favor, not for any, you know, not for any real functional reasons. It's still a possibility, but the one that's more likely and accounts for some of the chemical inconsistencies. So when I said they analyzed the moon rocks and it is our baby, it is. But if the Earth is the mother, then there is a father as well. So.
No,
Big reveal.
Big wave and it just popped. There's a word for when.
I'm afraid it wasn't immaculate conception. Well,
Does there have to be a daddy?
I can't be absolute about that. It may have been an immaculate conception, but your question, it's great we're still around Saturn, because Saturn is an excellent model for the early solar system when all of that was going on. And so your description, as I said, was brilliant. And you can kind of see it happening on a small scale in Saturn's rings, because these particles that make up the ring are not all of uniform size. And so just for visual sake, I keep forgetting to slow down and then I get all messed up. For visual sake, I'll just get back into the ring so we can see these particles. Now, the process that I'm going to describe is not actually depicted in this simulation, but you can kind of reason it through here. So we have particles of different sizes here, and all matter generates gravity. I'm exerting a gravitational pull on all of you right now. I'm definitely exerting more than most of you. But you're all doing your part as well. The fireplace is pulling on me. All of it is imperceptible because gravity is extremely weak. You need a lot of matter to create a noticeable pull. And we have a lot of matter right under us pulling us down. So the Earth creates this gravitational pull from the mass of all of its matter. However, if you have all of this material that's just, you know, bobbing along in its own, or not bobbing is the wrong word, just strolling along in its own path along with all of its buddies, then the gravitational pull between these guys, given years and years to play out, actually starts to have some influence.
The Uncle Gold Podcast.